1916, a chemist by the name of Lewis decided to come up with a way to show people a way of thinking about how atoms are bonded together in what we call covalent molecules. I'm going to show you how to do Lewis electron dot diagrams by example. So, the first thing that we need to do is figure out how many valence electrons each of the atoms in this formula are providing. So, in the formula, we've got 1 carbon atom, 4 chlorine atoms. I'm going to use a periodic table to figure out how many valence electrons each of these atoms is providing. On this periodic table, we see that carbon is located here, and that's in the 4th column if we're considering only the group A elements. 1, 2, 3, 4. That means it has 4 valence electrons. Chlorine is in the 7th column over. 1, 2, 3, 4, 5, 6, 7. Each chlorine atom provides 7 valence electrons. The thing to help you figure out how many valence electrons an atom has when it's involved in covalent bonding, a tricky way of doing it is to look at the top of your periodic table, and most periodic tables will have the group number in Roman numerals with an A after it. That'll just tell you how many valence electrons are in the group. So, for example, carbon would be group 4A, 4 valence electrons. Chlorine would be group 7A, 7 valence electrons. So now I'm going to figure out how many electrons in total valence electrons in total are going to be in this molecule. There's 1 carbon. Each carbon has 4 valence electrons. There's 4 chlorines. Each chlorine has 7 valence electrons. Now I'm going to figure out the total number of valence electrons that are in the molecule. 1 times 4 is 4. 4 times 7 is 28. 4 plus 28 is 32. 32 valence electrons are in the molecule. Now, the idea here is that it's kind of like going to a potluck dinner, writing those electron dot diagrams. If you go to a potluck dinner, everybody brings something to eat, and at the end of the dinner, hopefully there are no leftovers and you didn't have to order out for extra food. Same idea with the Lewis electron dot diagram. Think of the electrons as dinner items. So what I'm going to do is I'm going to draw a picture describing how these valence electrons are distributed in this molecule. And I have to use up all of the electrons, all of the valence electrons that are available, and I can't go get any more from anywhere. Here we go. It's a procedure I'm going to show you. I'm going to put the carbon as the central element because the carbon's first in the formula. And this is almost always the case. I'll do an exception to that situation later. I'm going to next put the 4 chlorine atoms around the carbon atom. The chlorine atoms will be the outside atoms, the carbon atom will be the central atom. Next, I'm going to connect the central atom to the outside atoms with a single bond, which is the sharing of 1 pair of electrons. Single covalent bond. To indicate that the bond is being it results from the sharing of a pair of electrons, I'm going to put 1 electron pair on each of those bonds. The next step in the procedure is I'm going to make the outside atoms in this molecule happy. As it turns out, the outside atoms will want to have 8 electrons around them so that they have a completely filled energy level. So if chlorine has 8 electrons around the outside of it, it will have a completely filled energy level and it'll be stable. In other words, happy. So the chlorine sees 2 electrons in this bond. It wants to have 6 more, so I'm going to give it 6 more. Now this chlorine atom would see 2, 4, 6, 8 electrons, and it would be happy. Next, Go to the next chlorine atom on the outside. The next atom on the outside also wants to have 8 electrons around it. It sees 2, wants 8, so it needs 6 more. Give it what it wants. The next one sees 2, wants 8, needs 6 more. And the last chlorine that we're talking about also sees 2, wants 8, needs 6 more. The next step in the procedure is to consider the central atom. The central atom, the carbon atom in this case, sees how many electrons? 2, 4, 6, 8. It also must have 8 electrons around it. So it wants 8, it sees 8, it's happy. Finally, what I'm going to do is I'm going to add up the number of valence electrons I've used to make this Lewis electron dot diagram. Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. This diagram has 32 electrons in it. I had 32 valence electrons to distribute, so this is a happy Lewis electron dot diagram.